Good evening, everyone. So, in today's class, we will discuss the statement, the proof, and one of the examples of the Bayes theorem. This is a very important concept of the class 12 probability chapter. Okay. So, first we understand where to use the Bayes theorem. So, let's see a problem. Suppose there is a retailer who sells the bulbs. He bought bulbs from three different factories, say factory number A, factory B, and factory C. From factory A, it receives 40% bulbs. From factory B, it receives 30% of bulbs. And from factory C, it receives rest of 30% of bulbs. Okay. Now, all three factories have an issue that they produce a little bit amount of defective bulbs. So what are the amount of defective bulbs? Say in this 40% of bulbs, factory A produces 3% of defective bulbs. In this 30% of bulbs, B factory produces 2% of defective bulbs, and the rest of the 30% bulbs, factory C produces 5% of defective bulbs. Now, you are an inspector and you have to inspect some issues of this retailer shop. Now, if I ask you that you have to calculate the probability of, suppose you picked a random bulb from this retailer shop, and I asked you to calculate the probability that the picked bulb is defective. So what will be the probability that the picked bulb is defective? Now, you can easily answer this question using the concept of total probability. Suppose I am assuming that this is as event E1, which denotes that the bulb is from factory A. Bulb is of factory A. I am writing in short. And the event E2 denotes the event that the bulb chosen is from factory B. And E3 denotes the event that the picked bulb is from factory C. And I am denoting the event D as that the picked bulb is defective. Now, if I have to calculate the probability of D, it means that the picked bulb is defective. So what will be the answer? Using the total probability concept, we can easily solve that. What are the cases? The first case, that I can pick the bulb which is manufactured in factory A and it is defective. That's the first case. Second case will be, or the bulb which is defective, it was produced in factory B and it is defective. So that's the second case. And what will be the third case? Third case is that the picked bulb which is defective, it manufactured in factory C and it is now defective. So there are three cases of a bulb became defective. So what are the probability of that? First of all, for the first case, I pick the bulb and it is manufactured in factory A. So what will be the probability for that? That is probability of E1. And it is defective. So I picked a bulb which was manufactured in factory A, then it is defective. It will be this. By conditional probability, probability of D bar E1. It denotes that the bulb which was picked, it was manufactured in the factory A and now it is defective. Similarly, I can write the second case, that the bulb I picked, it was manufactured in factory B and it is defective now. Similarly, the third case, that the bulb was manufactured in factory C and now it is defective. Now, as you can see, if I go through this place, the probability that the bulb is manufactured in factory A is 40%. That it means it is 40 by 100. Similarly, probability of E2 will be 30 by 100 and probability of E3 will be 30 by 100 too. Now what will be the conditional probabilities? So if you see that 3% of bulbs are defective in factory A, so the DE1, first of all, it is 40 by 100 into, this is 3%, it means it will be 3 by 100 plus probability of E2, that is 30 by 100 into, what is the percentage of factory B, that is 2%, so it means it is 2 by 100. Third, what is the probability of E3, that is 30 by 100, and what is the probability of the bulb being defective if it is produced in factory C, that is 5%, it means 5 by 100. So if you calculate all of this, you will get the answer of, let's just calculate it, 0.033. You can calculate it easily using the calculator or by manually. Okay, so that's the answer of my first question, that I picked a bulb from the retailer shop randomly, and what is the probability that it was defective. Now the second question arrives, and where the uses of Bayes theorem will come. That I picked a defective bulb. Now what is the probability that it was made in the factory number A, or it was made in factory number B, or it was from factory number C? Just the inverse of these probabilities. This conditional probability denotes that I picked a bulb which was manufactured in factory A and it is defective. But what will be the inverse of that? That I picked a defective bulb. Now find the probability that this defective bulb is from factory A. So that will be the conditional probability. Similarly, if I want to find the probability that I picked a defective bulb, now what is the probability that it was made in factory B? That will be this conditional probability. Similarly, for the factory C, this will be the required probability. Now how we will calculate that? Now we will use the Bayes theorem. So what is the definition of Bayes theorem? Let's go through that. So Bayes theorem suggests that suppose we have E1, E2 up to En be a set of events associated with a sample space S, where all the events are mutually exclusive. What does it mean? Mutually exclusive mean if I take any two events, they are disjoint. It means they doesn't have any kind of common elements between them, and they are exhaustive. What does it mean? Exhaustive means if I take union of all of them, then it will give me the sample space S. Okay, now let A be any event associated with S, and if we know the probability of E1, E2 up to En and the conditionals probability A bar E1, A bar E2 up to A bar En, then if I have to find the inverse of these probabilities, like probability of EI bar A, then this is the formula, that is probability of EI into probability of A bar EI divided by the total probability of A. This is nothing but the total probability of A. Now how this formula came? So let's go through the proof. Now two conditions are given, that if I take any two events, they are mutually exclusive and they are exhaustive. It means if I take E1 union of them, then it will give me the sample space. Now suppose I have another event A associated with this sample space S. Now we all know that events are the subset of sample space, so I can write this, that A is a subspace of the sample space. Now as A is the subset of sample space, can I write this? A equals to S intersection A. This will also give me A. Now we know that S is nothing but E1 union E2 up to En intersection A. Now if we distribute this intersection along this union, then we will get A intersection E1 union A intersection E2 union up to A intersection En. Now if we take probability in both sides, we will get that the total probability A is equals to probability of A intersection E1 plus probability of A intersection E2 and up to probability of A intersection En. Now by the definition of conditional probability, I can write this as probability of A intersection E1. It can be written as probability of E1, probability of E1 into probability of A bar E1 by the definition of conditional probability. Similarly, I can write this probability of E2, probability of A bar E2 up to probability of En, probability of A bar En. As we know that the definition of conditional probability, if we have A bar E, what does it mean? The conditional probability A bar E means probability of A intersection B is divided by probability of B. Okay, I just used this formula. Now we know that probability of EI intersection A, it can be written as in two ways. First of all, probability of A into probability of EI bar A, or I can write this as probability of AI or EI into probability of A bar EI, both from the conditional probability definition. Now if I take probability of A bar EI and write this as probability of EI, just give me a pardon. If I take this equation and write probability of EI bar A, it will be probability of EI into probability of A bar EI and divided by the probability of A, and that is nothing but, if I see only the denominator, this is nothing but, I am writing only the denominator, this is probability of EI into probability of A bar EI. So that's my Bayes theorem statement which was proved now. Okay, so let's go through the proof. Now we will use this theorem to solve our problem. Now let's see, I will do only the first case. Now using Bayes theorem, I want to find that if I pick a defective bulb, what will be the probability that the bulb was made in factory A. So that is the conditional probability, that I picked a defective bulb and it was made in the factory A. So using Bayes theorem, I can write this as probability of E1, probability of D bar EI divided by the total probability which was already calculated here, that is 0.033, that is 0.033. Now if I put the values here, what is the value of probability of E1, that the bulb manufactured in factory A, that is 40 by 100, into what is the probability that it is defective, 3 by 100, now divided by 0.033. Now I have to calculate the probability of that. Just give me a minute. Let's calculate it manually. So that is 120 divided by 1000, 4 zeros are there, and divided by 0.033. So our answer will be 0.363 approximately. So that's how we use the Bayes theorem in our problem solving. So now I hope you can easily calculate this and this also. So write down the answer in the comment box and see you guys in the next video.